On the last part of my video series, I received a comment about caching opcodes in our Chip8 emulator, and I decided to have a look into that. So for the past few days, I've been working on opcode caching for this emulator, and I think I found a spot that I want to be at. So I'm going to go ahead and make some changes here just to show you how I want to do things moving forward. I did test this code in my already completed emulator and things did work, and I did see some performance benefits. So I thought, why not just insert it here rather than later? Because if we change it later, it would be a lot more code to move around. So here I'm going to put in a structure where we can store our opcodes and our data for each opcode. So then whenever the opcode is called again, we can just point to that structure rather than decoding the entire opcode again each time it's called. That way, all of our work's already done for us, and we can save performance by doing this. First thing I'm going to do is make a structure here. I'm going to call it type-def struct. And what we'll do is we'll put in our data that we need. We'll call this optype. Then we'll put in 8-bit. We need one for our X. We need one for our Y. And you may remember from the last part, we had functions to pull different parts of the opcode out. So we're going to be storing those in here as well. So we're going to call this one N, and we're going to have another 8-bit value called KK. Uint 16, which is triple N. And then uint 8 subtype. So the subtype is going to be used to differentiate between the opcodes that have multiple different types. So for example, the opcodes that start with an 8, we can use the subtype to switch between them rather than having to make a new one for each and every one. And we'll call this cached OP, as in cached opcode. And because we're doing things this way, we can actually get rid of our helper functions here. At least just these 4. The way that we're going to be doing things is using the structure, so we don't even need to have those helpers anymore. We can delete them from cpu.c later, but we'll hold off just for now. We're actually going to make a new helper function. We're going to call it void clear cache. We'll make one more called cached op, as in cached opcode, for our actual structure. We'll call it decode opcode. And there we'll pass the opcode in the parameters. So when we're doing this, we're actually going to have 3 different functions to handle fetch, decode, and execute properly, rather than doing everything in just the execute opcode function. This will make more sense as we get closer, but I think in the long run, this is going to be a much better way to handle this. Okay, so heading into our cpu.c file, if we scroll down, I want to go past fetch opcode here. And if you look at execute opcode, we're going to get all these errors because we no longer have these helper functions. That's okay, we'll work on that later. Right here with fetch opcode, I'm going to put the decode opcode function right underneath it. So the idea behind this function is to put all of our helpers basically in one place, decode the opcode, and place it in the structure, so then we have the opcode permanently decoded. So what we're going to do is we're going to start by making the structure. We'll just call it OP. So from here, we need to get each variable to fill in the structure. We'll start with optype equals opcode and 0xF000. So all this does is get the first or the most significant bit of the opcode. Next one, we can get our X value. We know it's at this position, and we need to bit shift it by 8 in order for it to be its own standalone 8-bit value. Similar deal with Y, you're going to get opcode and 0x00F0. We only need to bit shift it to the right by 4. Now we may not need this value very much, but we're going to put it in here anyway. Code and 0x00F going to be our single n value. We call the double value KK. Put the two F's there. And then for the triple N, we'll get all three. And then from here, we can just return the structure. So the way that this works is that we're going to take an array and store our actual opcodes within the array. There are different ways of doing this, but because the Chip8 isn't as big, as I've said many times, I'm just going to use the standard array to actually store our opcodes. So we'll make the array of the opcode structures here. I'm just going to call it cache. Call it cache size. And our cache size we'll define right here. We'll just make it 4096 minus 0x200. So it's basically the same as it is as the max ROM size, but I'm going to call it differently to avoid any kind of confusion. We'll make another array called static bool cache valid. And the reason that we're making two arrays is because if we make an array where it is just Boolean values, we can easily tell whether or not there's actually something stored within the cache array. It's easy for us to just check, and if it's true, then we know that it's in the cache array. That way we're not reading from just garbage. We now have one helper function that we still need to add before this will be functional. So we need to go to the bottom of our file. And this is a great time for us to remove all of the old helper functions while we're down here. And our helper function is void clear cache. And all it is a simple mem set. So now we'll go back up to the CPU initialize function, and we'll start there with modifying each and every function to accept our cached opcode rather than how we were doing it before. All that we really need to add here is just the clear cache function, just to make sure everything is initialized and ready to go. The next thing we need to do is we need to modify our program cycle function. Most of the logic here still applies, but what we need to change is we need to add a check for our cache valid array, and we need to make sure that we have an opcode there. And if we don't, we know that we need to add the next opcode into that part of the array. So after our program counter increment, we're going to go ahead and make an if statement. We'll check the cache, and we'll check it at the address. And because we no longer need this here, we can actually take this out, and we'll put a check for the address. So we know that if the cache is valid, we know that there's already a decoded opcode there. So we can go ahead and just grab it. Just need the address of the cache at the address. And we are going to see an error here because if you look down here at the execute opcode, it's expecting a 16-bit opcode and it's not expecting this value from our actual array yet. We'll change this here in a moment, but you can go ahead and ignore this error for now. So if the array returns false, then we know that we need to take our opcode, decode it, and then put it into the array. So what we will do here is we will grab our opcode, and then from here, we're going to take our cache at the address, and we're going to set it to the return of decode opcode, and we'll pass along the code that we just grabbed. From there, we'll set the same address at cache valid to true. So then we know that if there is an opcode there, all we need to do is check the cache valid array. And if it says true, then we know that there's an opcode there. Then from there, we can execute our opcode. We can go ahead and get rid of this old one. So because we are incrementing our program counter right here, we actually do need to go to our fetch opcode and we need to add that parameter. So we need to add a parameter for our address. And we can change these calls to our program counter to the address. And make sure to update it in your header file as well. Since we're here in the header file, we're going to also change this around for the execute opcode. And this will allow us to send our pointer to the opcode within the array, so then from there we can execute it from there and not just from the direct address. Okay, back in our main C file, there's a couple things that we're going to need to change for our execute opcode function. First off, we need to change our parameter. And then from there, we can actually get rid of all of these function calls. And in our switch statement, we're instead going to be referring to the structure that we passed in the parameters. And we can refer to the optype within the structure. You may be wondering how we can tell between the inside cases for when we have multiple of the same opcode type. And the way we do that is by looking at the cases. If you take a look, the least significant bits, we have an E0 here and an EE here. So we know that those two values are the ones that we need to look at. And we already have a variable within our structure with two values, and that is OPKK. So we can use that to tell which opcode it is that we actually need. And scrolling down here, the last thing we need to change is we just need to refer all of these within the structure. So from there, we just add OP, triple N. Coming down here, we do the same thing. In here, we have our X value. And we have our KK value. And then from there, we just get all the rest. And from there, we are done. So to recap, the way that this works in our program cycle is we are taking the address in the program counter, we are checking our cache valid array to see if it is true or false. If it is true, we can execute the opcode at that address of the cache array. If it is false, what we do is we take the opcode by calling fetch opcode, we then decode the opcode in the function that we wrote up here, we then set the cache valid at that location to true, and then from there we can execute the opcode. And then from here, the execute opcode function is just updated to use the structure rather than our helper functions that we had before. I feel like in the long run, this is going to be a much safer bet and things are going to run a lot better. I know that this is a bit of a deviation from what we were doing before, but I took this as a learning experience for myself because I wanted to make sure that I'm making good code and that I'm teaching you to make good code as well. So if you have any other suggestions, please let me know. I'm always open to hearing new things. I don't claim to be the best programmer in the world. I'm learning just as you are. So when people make suggestions like that, I like to try and learn. And if I can find a better way to do something, then I will do it. And I hope that with this part in between our opcode implementation, it helps you learn something as well. If you have any questions, please leave them in the comments below. Hope to see you in the next part.